We are going to look at our binary search tree, and we're going to specifically be looking at the Python code that we need to write a binary search tree when we want to insert a binary search tree. So the previous lessons we've looked at the strict rules behind creating a binary search tree. So the first node is always going to be the root. Then the subsequent nodes, we look and compare it to the root or to the parent, and then we decide where it should go. So in this case, F is bigger than the letter D, so F is going to go on the right side. So the aim of today's lesson is to look at the Python code itself and have a trace. So walk through step by step what is happening when we insert a number in our binary search tree. Finally, we will then touch a little bit on traversal, how we're going to print our binary search tree out. Okay, first let's look at the code itself. So the first couple of lines is looking at the object node. When we create the object node, as you can see, it takes the value we've put in, but the left side of our node is going to be none, and the right side of our node is going to be none. We're going to create a node. The first one we create is always going to be the root. So when we create a node, the left side and the right side is going to be set to none. Now the none could be any letter you choose, but I've just chosen none just to make it easier. And this is the pseudocode we did last lesson. So let's just quickly look at the two together. So the pseudocode and the Python code. So this is the base case, and the base case is used to create a new node. Now we always need to create a new node when it's the root. So the first node is always going to be the root. We also need to create a node when we need to insert a new node. And every time we need to insert a new node, we can't insert it unless the right side or the left side of the parent is none. So this is the base case that checks that. So only create a new node when the right or left is none. It's a recursive algorithm as well. So it means that when we get to none, let's say 8 is the root, we create a new node. This ensures that we create a node only when a space is available as well. So if the space is not available, our algorithm, our code is going to keep going, repeating itself until it finds a space. The next part of our code is when we insert another node. The second node is going to kind of look whether it needs to go right or left. So here we need to check if the value of the next node is smaller than the parent. So this is checking whether it needs to go left or right. If the value is smaller than the value of the parent, then it needs to go left. And because it's a recursive algorithm, it's going to keep looking on the left until there's space available. So until we've reached the base case. The base case is when you look on the left side, it says known, then you can create a new node. So that point is when we create a new node. If it's not going to the left, then it means the number must be bigger. So the right subtree rule, all the values in the right subtree are bigger than the node's value. So this is checking whether it goes to the right now. So if the value of our new node is bigger than the value of the parent, then we are going right. Again, there's a recursive part, so the call stack is going to keep calling until node.write is none. and then we create a new node if there's space available. Now, at the end of that, a node is returned. So this line here, you have a returned node. We're now going to trace our code to see what happens when we insert 8, 3, 10, 1, 6, and 14. So the first part of our code, root is none, so there's nothing there. We insert the number 8. So using our for loop, the first number we're inserting is the number 8. Now the root is none. When the root is none, what is going to happen is that we're going to call that function, but the root is none. So we're now going to return the node 8, and we're going to create a new object, a new node with a value of 8. So at this point, it's going to call for an instance of the node, so node 8. Now, the left of 8 is none and the right of 8 is none. We're now going to return the node. Now, this part is going to actually return 8. So the root is going to be 8. So once we finish the first node, which is 8, we now need to repeat. The next number we're inserting is the number 3. Well, when we insert the number 3, the root is 8. So we're going to have insert 8, 3. Now we're going to call our function. But when we call our function this time, the node is not 8. The node is actually 8. So we check what's the value? Is 3 smaller than 8? Well, yes it is. So we're going to call this and say, well, what number is on the left of 8? So here, what number is on the left of 8? Well, we know the left of 8 is none. If the left of 8 is none, it means that we're going to return node.left is null or known, and therefore, when we get to that stage, the left of 8 is none, which means we can now reach our base case. So the left of 8, we're going to put the number 3. So we're now going to create a new node, 3. And we insert it on the left of 8. On the left of 3 is none, on the right of 3 is none. So that's very important. Right, next we're now going to return our node. So we're returning 3. Now remember the number for the root is 8. We want to insert 10. If we go on this line, insert 8, 10, and then we go back to the insert function. So we would have insert 8, 10. Well, the value of 10 is bigger, so we're not going to go into this if loop. We're going to go into the else if. Well, we then check the node to the right. The node to the right of 8 is actually known. So if that is the case, remember we're going to actually call the recursive function again, so the call stack. The right of 8 is none. Because the right of 8 is none, we're going to now look at the right of 8 and we want to insert the number 10. So we're going to create a new node. Okay, and the new node 10 is then inserted to the right of 8. Left of 10 is none, right of 10 is none. Right, so that's what it will look like in our first 3 numbers. So 8, 3, and 10. If we want to insert the number 1, again we'll look at the left of 8, we get 3. Then we look at the left of 3, we get none. So we know that 1 is going to be inserted to the left of 3. We do the same for number 6. Well, insert 8, 6. Well, the 6 is smaller than 8, so we go to the left. Well, the left of 8 is 3, so it's not none. Then we look, well, 6 is bigger than 3, so we want to go to the right. Well, the right of 3 is none. Because the right of 3 is none, we're going to create a node and we're going to put our 6 there. Your turn now. Pause the video. See if you can fill in the missing part of this for inserting 14. Right, let's see how you get on. So 8, 14. Well, 14 is bigger, so we're going to the right. Well, the right of 8 is 10. So we know we can't put it there because it's not none. Then we need to look at comparing 14 and 10. Well, 14 is bigger than 10. Well, the right of 10 is none. So that means we have a space available. We can now create 14 on the right of 10. Now I'm going to show you how we can print our code out. So we call this traversing a tree. And this is, imagine you want to walk through this part and visit all the nodes. Now, how would you go about doing this? Now, there are a couple of ways we can do it. There are actually 4 different ways, but we'll talk about that in our next lesson. So traversal, the 3 ways we can traverse a tree: in order traversal, pre-order traversal, post-order traversal. We can also do what we call a breadth first traversal, but we'll talk about that more in the next video. So this is our code for in order traversal. So what is going to happen is this. This is actually our code. So this is the full code. So on our full code, I would like you to actually try to type this out yourself and see how it goes. Now you can test it out. So do your own testing. See if you can change the numbers here and see what happens when you print it out. If the video has been helpful, please click the like button. Alright, this is what the code should look like once you've written it out in your IDE. So you've got the codes, then you've got the function to insert. At the bottom, I've given you how to print it out. So if I run this code, the printout should be 1, 3, 6, 8, 10, and 14. Alright, thank you for watching. See you in the next video.